Hi, fourth graders. Today we are going to be talking about factors and factor pairs. Before we get started in the lesson, I want to review what those mean. So a factor is one of the two numbers you use in a multiplication problem. So you can see that there is a 4 times 2, and your answer is 8. So 4 is a factor and 2 is a factor. Factor pairs are two numbers that are multiplied together to give a product. So 4 and 2 are factor pairs for the product of 8. So keep in mind that a factor is a single number and a factor pair is two numbers, like a pair of socks. Okay, so let's move on to our first. We're going to do a warm up. I want you to write the multiplication equation for each array. So this array has one multiplication problem and this array has a different one. Go ahead and do that now. All right, so if you wrote 2 times 4 equals 8 under this array, that is correct because you see two groups of 4. And if you wrote 4 times 2 equals 8 here, that is correct because you see 4 groups of 2. And although the product or the answer is the same, the picture looks different and the multiplication problem should match the array. Okay? All right, let's move on to the next one. Alfred is arranging 40 model cars into rows. He wants to put the same number of cars in each row. Find all the ways he can arrange the cars. All right, so let's think like we've done every time. What is this problem about? Go ahead and do that now. What is this problem about? Alfred is arranging 40 model cars into rows. He wants to put the same number of cars in each row. Find all the ways he can arrange the cars. What is this about? Okay, now we're going to do the second question. What are you trying to find out? What are you trying to find out? I want you to think about that. And then what information is important? So if in the first question you answered this is about model cars, arranging model cars, you're correct. We are arranging 40 model cars into rows. What are we trying to find out? We're trying to find all the ways he can arrange the cars in the same number of rows. What information is important? 40 model cars is important, and the same number of cars in each row. Very important. You can't have rows that are different numbered cars. So I want to start you out with one that I know of that could be an easier way. One row of 40. I can put them in one long row of 40 cars. Okay, now I want you to try to see if you can find other ways to arrange 40 model cars in the same or in each row with the same number of cars. I will give you a hint. There are 3 other ways. Go ahead and try. Okay, so hopefully you were thinking of factor pairs. In this case, 1 times 40 equals 40. So that's one way I could arrange my cars that have the same number of cars in each row. Let me show you another way. On this slide, I can see that Alfred arranged his cars in 5 rows of 8. So I can see an array here. I see 5 cars going down and I see 8 cars across. And he did that. So if you were to count by 5s, you could go 5, 10, 15, 20, 25, 30, 35, 40. Okay, but he did 5 rows of 8. So 5 and 8 are a factor pair of 40. So this means Alfred could also arrange his cars into 8 rows of 5. So that would look a little different. That picture, instead of having 5 rows, it would have 8 rows, and it would only have 5 cars in each of the rows. And I know this because 5 times 8 is 40. So those are factor pairs of 40. So far we've had 1 times 40, the one I gave you, and now we have 5 times 8. Let's see if there's another way. Here are two more ways. Alfred can arrange cars into 10 rows of 4. That's this right here. Or 2 rows of 20, because I know half of 40 is 20. So 2 and 20 and 10 and 4 are factor pairs of 40. This also means Alfred could arrange the cars into 4 rows of 10, and he could also arrange the cars into 20 rows of 2. So you can see that they are just switching the place of the factor pairs. 2 times 20 or 20 times 2 is the same answer, right? The picture would look different, but they're the same factor pairs, even though they're in a different order. So 10 times 4 or 4 times 10, those are still the same factor pairs, okay? So I want you to be thinking of all of those factors and factor pairs that we just came up with. And I want you to take this moment to see if you can list all the factor pairs. So when you're listing pairs, you want to say 1 times 40. That is a factor pair. So now I want you to think of the other factor pairs that we just came up with or we just read about in the last couple of slides. Go ahead and do that now. Okay, so if you wrote down 2 times 20, great job. If you wrote down 4 times 10, great job. And then there was one more factor pair, and that last factor pair is 5 times 8. Okay, those are the factor pairs of 40. So each number in a factor pair is a factor. Remember, I started out by saying a factor is a single number and a factor pair is 2. So each number is a factor pair, or each number in a factor pair is a factor. So how many factors does 40 have? Look at all these pairs. How many factors does 40 have? Go ahead and do that now. Okay, so all you had to do was count up each of the factors. So I have 1, 2, 3, 4, 5, 6, 7, 8. So then how many factors does 40 have? It has 8 factors, 8 different factors, 4 factor pairs, but 8 factors. So one way I like to think about factor pairs is arranging them and starting with the number 1. And this question says, why might it be helpful to start with the number 1 and work up when finding factors of a number? And so I'm going to let you know that my answer to that would be, if you start with 1 and you go in order, you're not going to get confused about which numbers you've worked with and which numbers you haven't. If you skip around and go, oh, 5 is a factor, oh, 2 is a factor, oh, 10 is a factor, then you get out of order. So if you start with 1 and ask yourself, is 1 a factor of 40? Well, just so you know, 1 is a factor of every number, right? Okay, so then I'm going to go to 2. Is 2 a factor of 40? Yes, 2 times 20 is 40. And then I'm going to ask myself, is 3 a factor of 40? Well, I know 3 times 10 is 30. Ooh, 3 times 11 is 33. And if I keep counting by 3s, 36, 39, 42. No, 3 is not a factor of 40, so I'm going to move on. Is 4 a factor of 40? Yes, 4 times 10 equals 40. The next number is 5. Is 5 a factor of 40? Yeah, we found out that 5 times 8 equals 40. So then I'm going to ask, is 6 a factor of 40? Well, I know 6 times 6 is 36, and 6 times 7 is 42. No. Okay, then is 7 a factor of 40? 7 times 5 is 35. 7 times 6 is 42. No. So my next number would be 8. Well, I already have 8. It's right here. Once I start repeating a number that I already have, I have found all the factors for that number. So in this case, there are 4 factor pairs for 40, 8 factors. Looking at this next one, I'm going to ask you guys to try this on your own. Brad has 18 blocks. He wants to make an array with the same number of blocks in each row. What are all the different ways Brad can arrange blocks? Show your work. I'm going to give you that first one because remember, 1 is always a factor to every number. So we have 1 times 18. If you go in order like we did on that last slide, I want you to see how many factors and factor pairs you can come up with for making an array that equals 18. Go ahead and do that now. Okay, so I started you out with 1. What comes after 1? 2. I know 2 is a factor of 18 because 18 is an even number. So I asked myself, 2 times, let's see, 5 is 10, 2 times 6 is 12, 2 times 8, 2 times 9 is 18. Okay, let's go to 3. 3 times 5 is 15. Ooh, 3 times 6 is 18. So now I have 3. So now I'm going to go to the number 4. 4 times 4 is 16. And 4 times 5 is 20. So 4 is not going to work. Let's look at the factor of 5. Well, I know 5, if counting by 5s, it has to end in a 5 or a 0. And 18 doesn't end in a 5 or a 0. So if I count it by 5s, 5, 10, 15, 20, I'm not going to land on 18. Okay, let's talk about the next number would be 6 then. Ooh, look, 6 is here. I'm already repeating my factors, so I have found all the factors that I can for 18. So it says, what are all the different ways Brad can arrange his blocks? He can do 1 times 18 or 18 times 1, right? He can do 2 times 9 or 9 times 2. He can do 3 times 6 or 6 times 3. He could have arranged his his blocks in a number of different ways. Let's try one more for practice. What are the factors of the number 27? Show your work. Okay, I want you to think of all the factor pairs and list the factors out. All right, go ahead and go. Okay, so factors of 27. Well, I'm going to start with 1 because I know 1 times 27 is a factor pair. All right, so now I'm going to go to 2. 2. No, 27 is odd. So 2 is not a factor of 27. All right, let's go to 3. 3 times, let's see, 3 times 10 is 30. Oop, that's too many. 3 times 8 is 24. 25, 26, 27. Ooh, 3 times 9 is 27. Very good. Okay, let's talk about 4. 4 times 5 is 20. I know that. 4 times 6 is 24. 4 times 7 is 28. Ooh, just missed it. Not going to work out. 5. I know 27 isn't a factor of 5 because if I count by 5s, I'm not going to land on 27. 5, 10, 15, 20, 25, 30. Nope. Let's do 6. 6 times 5 is 30. So 6 times 4 is 24. All right, how about 7? 7 times 4 is 28. Ooh, just missed it. 8. 8 times 3 is 24. So no, 8 times 4 is 32. And then the next number we come to is 9. Oh, 9. We're already there. So I know I'm already repeating a number and I'm done. So now I'm going to list the factors in order. 1, 3, 9, and 27. So there are 4 factors for the number 27. Okay, you are going to go to your small groups and you will see what we are doing today with you. All right, have a great day.